Hello, everyone. When I graduated with my degree in chemistry, I went to work for the DuPont company. And I wanted to learn so much about plastics and composite materials. Like most young chemists and engineers, I wanted to develop skill deep in the field. I wanted to become a world expert. After 7 years and several assignments in plastics and manufacturing of composites and plastics, I was made an offer to become the technical director of another company, and so I left DuPont. A few weeks after I had joined that company, I was asked to be the president of that small irrigation company, and suddenly the shock was on me. I had to learn a lot of things besides plastics and composites. I had to learn how to be an entrepreneur. I had to learn about business. I had to learn about irrigation and agriculture. What a shock, and humbling too. But I was fortunate to have a group of associates who were dedicated and very, very capable, and the company became very successful. I found the broad perspective from this new assignment, this new world that I had entered, to be exhilarating and rewarding. After about 7 years, there was a merger with that company, and I was out of a job. My wife and I decided that it was time to come home to Utah. And after a brief job in new product development, I joined the faculty at BYU. My focus was again narrow in plastics and composites. In this new focus, I wanted to get to the edge of knowledge. In fact, maybe if not quite at the edge, I wanted to at least be able to look and see the edge from where I stood. And I wanted to tell my students about it. What a glorious experience these last 17 years have been here at BYU. Well, about 6 years ago, I was chair of the department, and as chair, I was asked to write a paper about the goals of our department and our place on this campus. After considerable reflection, I concluded that my department, and in fact the entire College of Engineering and Technology, was quite isolated from the rest of campus. We had few interactions with the other colleges, and almost no students outside of our major were in our own classes. I felt that engineers and technologists had a contribution that they could make beyond that narrow scope. I just had to try and find a way to do it. This situation of isolation disappointed me. And so, in wrestling with what to do, I encountered the civilization courses that are part of our general education requirements here at BYU. I saw that any department could teach these civilization courses provided they taught the established and required parts of the curriculum. These guidelines for the courses stipulated that you had to read certain authors and look at certain works of art and teach certain concepts. But they allowed sufficient flexibility that within that broad range, there were, at that time, 9 different departments that were teaching civilization, each with their unique flavor. And I thought, maybe I could do it too. Then the problem came, what am I going to use for the theme of my course? Now, I had thought about the many similarities between technology and the arts. I have been told, in fact, that the word techne, from which we get technology, means both art and craft in ancient Greek. And I realized that Plato's word form is preserved in the sciences for mathematical models. We call them formulas. Also, the word scientist was invented in the 17th century as an analogy to the word artist. Clearly, there were areas of overlap between my expertise in engineering and technology and the areas of arts within the concept of civilization that was prescribed for us in that course. Eventually, I concluded that a common area that I could use was the area of creativity. Seems like everybody who has made significant contributions to civilization has done them through creative efforts. The examination of creative people and creative periods has seemed a way to link science to the arts and to literature and to civilization in its historical sense. It also seemed to be a fun way to get a lot of people together and we could talk about some really interesting stuff. And that has been a wonderful, wonderful experience for me. But it has forced me to again broaden my view. No longer am I just in the narrow area of plastics and composites. I'm now looking across the broad scope of history from the beginning of recorded history to today. Well, that little story was meant to convey a theme that I would like to address in this talk. What are the advantages of having depth in one field and simultaneously having breadth across many fields? In a sense, that is the question that many of you students might be asking. You might wonder, why do I have to take those general education courses? They are irrelevant to what I want to do. They're just a series of hoops that I have to jump through. There may even be some faculty who laugh at my efforts to teach outside my field. They might say, we weren't hired to teach outside of our area. They might even wonder if they can successfully teach outside of their area. And believe me, I've wondered that many times myself. Today, perhaps with a little defensiveness and also a little encouragement, I want to tell you that great joy can come from learning broadly. It might be students taking GE courses. You probably won't get choked up like me. Might come from teachers who are preparing to teach outside their general area of focus. But let me tell you, it is wonderful. And you know, along the way for preparing for this civilization course, I came across a book by C.P. Snow, and that book was called The Two Cultures. The basis of this book was a lecture given in a situation much like today at Cambridge University in England by Dr. Snow in 1959. In that occasion, in his book, he identified two distinct academic worlds, science and humanities. He said, in our society, that is, advanced Western society, we have lost even the pretense of a common culture. Persons educated with the greatest intensity we know can no longer communicate with each other in their plane of their creative, intellectual, and above all, their normal life. It is leading us to interpret the past wrongly, to misjudge the present, and to deny our hopes for the future. It is making it difficult or impossible for us to take good action. This is a serious matter. How are we going to progress if vast parts of our society cannot even communicate effectively with each other? Will our future be determined by chaos? Snow used humanism and science as two ends of a spectrum, realizing as I do that there are many disciplines in between, and that this spectrum is an oversimplification. Nevertheless, I hope that you will all find yourself somewhere along that spectrum and allow my comments about scientists and humanists to apply to you in whatever field you may be in. In a way, therefore, my talk is an application of Snow's thesis to today's world, especially here at BYU, and in light of my own experience. Isn't it true that part of every person's life experience is an attempt to understand the world around them? This understanding provides personal inner peace and security. The reality is that the world is both technical and aesthetic. Both sides need to be comprehended to see things as they really are. I would, therefore, today, like to address two propositions which seem to symbolize this divergence in the world. Why should scientists read Shakespeare? And why humanists should read Einstein? First, if I may, a few words directed toward scientists. For several years now, I've been in a professional society that is struggling with regulations that are being imposed by the federal government, negotiated with the society on the manufacture of composite materials and the regulation of pollution associated with that manufacturing. This process, this negotiation, is of interest to other parties such as lawyers, politicians, health professionals, business professionals, and regulatory experts. But who controls this process? Up to now, all sides have accepted the scientists' data. However, there may come a time when the lawyers and the politicians will exert their tremendous power and simply take over. My purpose here is not to comment on the power of politicians or lawyers, but to encourage scientists to develop their own power so that if the decision really should be science-based, they can exert their influence. They can do it, but not as long as the public views them individually and collectively as being so wrapped up in their narrow field, their narrow technological world, that they cannot relate to the broader world. And that view of the public is often true. Rewards for scientists are usually related only to their narrow field, and so scientists tend to ignore other fields, except in a cursory way. No wonder scientists are rarely given the chance to make decisions that affect the wider population. The public not only doubts that many scientists can comprehend the world around them, but equally problematical, the public doesn't even think that scientists can explain their own work. Thus, we have scientific reporters who translate technical stories into everyday language. What's wrong with scientists explaining their own work? The answer is, sadly, that too often scientists are unintelligible to the general public, to the non-technically trained person. They tend to use scientific jargon that is confusing to outsiders, and math is part of that jargon. This tendency among scientists has reinforced the general feeling among the public that scientists exist in their own world. I'm reminded of Gulliver's third travel, when he visited a land where there was an island that floated over the world. This island inhabited by scientists and other elite. And they were totally detached from the world below them. I guess things weren't so different in the days when Swift wrote Gulliver's Travels than today. Equally troubling is the widespread feeling among the public that scientists are not even in control of their own technology. Why? Because scientists have too often failed to see or at least discuss the broad implications of their science. Perhaps the most prominent examples are the nuclear bomb, chemical pollution. Scientists have just made too many errors in judgment about the broad effects of technology. Scientists need to see the broad picture. Scientists need to craft reasonable arguments in light of that broad picture. They need to be persuasive to the general public. These skills are the skills of humanists. Scientists need to enter the world of the humanists, to learn those skills, to adapt their methods. And today I have chosen Shakespeare as the door into the humanist world. The question can be asked, why Shakespeare? Why him specifically? The most obvious value of Shakespeare is that, in my opinion, he is the greatest writer in the English language. Well-educated people all over the world are familiar with his works and discuss the concepts and plots of his plays as if everybody present was familiar with what was happening in all of Shakespeare's plays. And in fact, a knowledge of Shakespeare is required of all educated people. But there is much more. Shakespeare will help us express our thoughts by enriching our vocabulary, and to the extent that our thoughts are tied to words, he will help us by giving us new words. In fact, he invented over 2,000 of them. His works, along with the King James Version of the Bible, are the basis for modern English. Another advantage to reading Shakespeare is his ability to portray human emotions and problems in a variety of settings. For instance, in my civilization class, we read Hamlet, in part because Hamlet was a college student, and I hope that students can relate to him. For the scientists in my class, I go through this analysis. Hamlet was troubled because he didn't trust the data he was given. Hamlet decided to perform an independent experiment to see if he could confirm the data. He was successful, but then he didn't know what to do about it. What would be the proper action? What would be the timing of the action? These are problems scientists regularly experience. Now, I know Hamlet was not a scientist, but his problems have relevance for all of us, both personally and professionally. Because Shakespeare wrote about so many fields, just reading his works will give us a breadth. There are Shakespearean plays about war, rulers, lawyers, spouses, history, fantasies, family troubles, and love, all in rich and lively settings. Even if the play is totally unrelated to your professional area, the human dramas enacted will help you in your personal life by providing a broader, truer view. Scientific discovery is most beneficial when it's applied to human problems. These problems are best understood and therefore best acted upon by comprehending the human condition. And that requires a view beyond science. It requires the view of the humanists. Now, if I'd be so bold, I'd like to speak to those in the humanities. Equally tragic to the problems of the scientists in society is the plight of the humanist in today's world where technology is so prevalent. Where the scientist might think that humanistic studies are irrelevant, a statement I have often heard, the humanities student might feel intimidated by the world's emphasis on math, statistics, and science. That's another statement I have often heard. The humanist might also struggle to cope with the complexity of technology. Haven't we all had that trouble? The humanist might even feel depreciated and unheard when facing what seems like a steamroller of science and the scientific method. Even the methods of science, quantitative thinking, modeling, and experimentation, seem vastly different from the humanist methods of form, aesthetics, qualitative thinking, holistic views, and humanness. Humanists will understand that some aspects of the world are best understood through a particular language. Some things in the world are best understood through a technical language. Let me give you a couple of examples on both sides. At one time, in Spanish, I learned that the word aguantar has a rich meaning that is not very well expressed in other languages. Another example in Spanish that has particular pertinence for me right now is tranquilo. I need it. Similarly, humanists should understand that there are some terms in the world that are best conveyed through technological words. An example, I suppose, would be infinity, the meaning of which is rich within the field of mathematics. So why should humanists in particular understand Einstein? First, like Einstein, you must understand classical science. You must appreciate the world described by Newton and the other army of scientists who followed him. For them, the world follows laws which describe interactions between time, mass, and three-dimensional space. These interactions are regular, predictable, and capable of being modeled, often with mathematics. You must also appreciate that when a problem is too complex, it can be solved by breaking it into smaller pieces so that it can be solved. And that small piece that you can solve is where you start. In the view of classical science, the world is like a clock, regular and predictable. And science's job is to investigate and describe the laws that govern its functions. After gaining an appreciation for classical science, the humanist can then go with Einstein on a thought experiment to explore the outer edges of our existence. You will find that the classical concepts of predictable time, mass, and space no longer apply at extremely fast speeds. You might even travel with those scientists who succeeded Einstein and look into the smallest particles of matter and find that, again, classical relationships between time, mass, and space do not apply to electrons and other subatomic particles. Let me give you an interesting thought experiment right now. We now understand that most of the size of an atom is empty space. There are very small and dense nuclei surrounded by electrons which are moving at high rates of speed. But these electrons are a long distance away from the nuclei. Let's assume that we could eliminate the space and bring the electrons and the nuclei together as we would gather tiny marbles. If we did that for all of the people in the world, all 6 billion people, and brought the total mass of all of their bodies together, all of their nuclei and all of their electrons would fit easily into a small drinking glass. If we understand that the world is mostly regular and predictable, surely we would think that that wall is solid. But in yet another view, it's mostly empty space. I'll just comment in passing that Christ seems to have understood the emptiness of that space and had the ability to utilize its emptiness when he passed through the wall to visit his disciples after his resurrection. Humanists who enter the scientific world can make unique contributions. If we are to believe Thomas Kuhn's book, The Structures of Scientific Revolutions, all scientific data are filtered through the scientist's paradigm. Then, scientific output depends greatly on the scientist, just as artistic and literary output depend upon the artist and writer. The study of the relationship between artists and works is clearly the realm of the humanists. So humanists can then use those skills within the area of science. Traditionally, such areas in science have been the purview of science history. But I believe that if the humanists really understand the principles of science, they can make a contribution to science itself that is unique and insightful. Talk about the interesting perspective that humanists can give to models. Scientists use models constantly and treat them as if they were exact, when, in truth, no model is exact. Humanists can help scientists evaluate the types of models and even the use of models. We might conclude that models are no more than a convenient place to hang data. Even more, humanists might have a unique view of statistics or probability or of the uncertainty principle, especially as they are applied to humans. Think of the interesting class that a humanist could teach in the basic understanding of scientific phenomena. According to the new general education plan that is about to go into effect here on BYU campus, such an opportunity exists right now for humanists to develop a unique version of Physical Science 100 or Biology 100. There are, I believe, many other opportunities for humanists to contribute in science if they want to become involved. The mutual immersion of scientists and humanists into each other's disciplines seems to be like traveling in a foreign country. I love to travel, and have found that I learn much about another people when I visit them. Several years ago, Margaret and I decided that travel would be one of our mutual hobbies. We have found that travel together enriches our lives personally and deepens our relationship. Along that same line, Margaret regularly attends my civilization evening class, and she is an active participant in helping me prepare my lectures. Perhaps the scientists and humanists should visit each other's territories together. They might find new and immensely enriching insights. Just a comment about this idea of joint teaching. In some places it's good. And I thought initially that I might team teach my civilization course. Maybe choosing someone from the humanities to be my co-teacher. But I decided against it because I realized that I would depend upon the person from the humanities for all of the discussions about humanities, and I would never get to understand their methods and their thinking. Therefore, I decided that I would take responsibility for all aspects of the class. However, I visited with several in the arts and letters to help me gain that understanding. I would like to thank especially Professors Doug Bush, Wilfred Griggs, and Tom Plummer for their assistance and insights. Now I'd like to show how creativity is a basis for much of what I have discussed so far. In my class on the history of creativity, I ask students to take 30 seconds and write down all of the uses they can for a paper cup. Why don't you take a moment right now and think of a few uses? You got them? Some of the uses that are commonly given are to hold water, to hold lemonade, to hold marbles, to be a vase for flowers. Also, to be part of a telephone system with a string, to be a hat, to be a pig snout in a costume, to be ripped apart as kindling for a fire. These uses fall into two categories. Some focus on the cup as a container, that is, on its normal function. This is called fluency. And with only a little effort, we can logically think of dozens of fluency uses by just varying the liquids or the solids that the cup would contain. We might eventually explore the capabilities of the cup by looking at putting in various fluids like hot oil, and we might discover that the cup is destroyed. Or a solvent like hexane that might dissolve away the wax coating. These are logical investigations, maybe scientific-like investigations. When using fluency, we have a vision of the cup as a container. This is like saying the cup has the form of a container in the Platonic sense. The other uses for a cup examine its applications in ways that were not originally intended. These answers explore flexibility. We see them by analogy or metaphor. They are not logical, but rather intuitive. The two types of answers, fluency and flexibility, are really two different ways of thinking. I compare fluency to linear thinking. It is based on logic, focuses on the purpose of the item, and leads to a deep understanding of it. Linear thinking also involves experiences and skill. There is creativity involved, but it is creativity supported by logic and hard work. Flexibility is thinking lateral. This describes uses by analogy and depends on broad, non-logical thinking. It is more intuitive. It seeks uniqueness and innovation. It too is creative. These concepts of linear and lateral thinking were developed by Edward de Bono in his book, Lateral Thinking, from which I've taken many of these ideas. After describing these two types of thinking, I realize that they are analogous to left and right brain thinking. One hemisphere of the brain controls logic and gives us fluency. The other hemisphere controls intuition and gives us flexibility. I believe that creativity is best served when both hemispheres are put together, and thinking can be both fluent and flexible, logical and intuitive as needed. Perhaps that is why the two halves of the brain are referred to as hemispheres, implying that they are only parts of the oneness of a complete sphere. Another way to think of our brains is as filing systems. We have file drawers for certain subjects, such as chemistry. When we learn about chemistry, we put that stuff into the file. Most of our major education is involved in filling up separate file drawers. But occasionally we are asked for new and original ideas that require us to make connections with knowledge in a different field. This is like leaping from one file drawer to another. To accomplish this task, we need breadth so that we have many other drawers that we can search for an analogy and, in essence, make a leap to or from the file of chemistry. People can be creative in one kind of thinking, linear or lateral. But don't we appreciate the scientists, for instance, who have unique lateral insights in their reporting of their scientific data? or of the artist who, in addition to beautiful aesthetic content, has shown a tremendous skill and knowledge of the material when he presents his art. Here's another example. Louis Pasteur was one of the greatest scientists who has ever lived. He spent his life solving biological problems for French industries, from winemaking to dairy. He was, during part of his life, exploring ways to cure chicken cholera, a disease that had decimated the French poultry business. As part of his investigation, he was injecting chickens with a virulent strain of the disease, and then when the chickens got sick, investigating ways to cure them. One day after a vacation, he came back and found a syringe of the virulent solution sitting on the counter, left out of the refrigerator for the entire vacation time. Rather than waste it, he decided that he would use it, and he injected some chickens with it. After the incubation period of a few days, he found that the chickens were not sick, and he assumed that the virulent material that had been left out over the vacation was no good. So he got some new virulent material, re-injected those chickens and a few others. And then after another incubation period, he found that those chickens that had been injected twice were not sick. But the other ones were deathly sick. An unexpected event. Something new had happened. He thought about what had happened and realized that the previous material that had been left out over the vacation had been attenuated in its strength. He therefore seized this opportunity and developed an inoculation against chicken cholera. In Pasteur's own words, chance favors the prepared mind. Pasteur thought linearly in doing research, but used the strangeness of the data as a jumping-off point for lateral thinking. In my class on entrepreneurship for non-business majors, we discuss other situations that might be used to trigger innovation. Besides unexpected occurrences, these other situations might be incongruities, process needs, industry and market changes, demographic changes, changes in perception, and new knowledge. I submit to you that the ability to capitalize from these innovative moments comes from both depth and breadth, from both linear thinking and lateral thinking, from engagement of both the left and the right sides of our mind, from exploring both our own professional areas and areas outside our fields. Working on both linear and lateral thinking is hard work. It takes extra effort and much time to learn outside your area. But if you will do it, you will be rewarded with a greater appreciation for others and greater personal creativity. As President Spencer W. Kimball has said, those tremendously useful men, those powerful and invincible men, Marconi, Edison, Orville Wright, Burbank, who sit wrapped in purple robes of creative genius, are simply men who are capable of striking reiterated blows. They are men who reach success because they subjected themselves to the fierce fires of intellectual and physical endeavor. Men never ascend to eminence by a single leap or by growth overnight. Longfellow gave us this: the heights by great men reached and kept were not attained by sudden flight, but they, while their companions slept, were toiling upward in the night. Too many engineering students come to me with an idea to form a company, but they have absolutely no appreciation for the business side. They think that the world will beat a door to their path just because they've got this good product. Equally sad are the many business students who come to me with the idea for a product, but assume that marketing is trivial and they haven't any idea about how it will be done or the costs involved. We all need to explore the territories of others, and that is true for both students and faculty. A liberal education has always involved students in both humanities and sciences. This was true in Aristotle's Lyceum and throughout the Middle Ages, when the trivium and quadrivium were the curricula for a proper education. Today we have general education, which is hoped to give us the broad perspective to encourage lifelong learning across many fields. I think that the concepts of general education and lifelong learning should apply to faculty throughout their careers, just as they apply to students. Breadth will help the faculty in their own lives, and they will be better mentors and examples to their students. The separation of our disciplines has occurred in part to facilitate logical development of each discipline and to allow us to teach the vast amount of knowledge accumulated in each discipline. But maybe we should be less concerned about content and more concerned about how to think creatively. We believe that proper rigor in the field requires depth. Maybe we ought to rethink the definition of rigor. Also, because the faculty are currently promoted on the basis of their research contributions, that places a premium on depth. We might rethink that also. The world, too, is compartmentalized so that we can contribute to a specific field that probably requires skill and training, both of them linear in nature. However, I would like to read a quote on this matter from Gerald Zaltman, professor of business administration at Harvard. I don't buy the notion that the world is organized the way universities and companies are. Ideas don't know what discipline they're in. We might kidnap them and say that's a marketing idea or that's an anthropology idea. But if you walked up to an idea on the street, it wouldn't know about that. I believe that exploration of areas outside your major by both students and faculty will be especially rewarding for BYU and greatly add to the aims of a BYU education. We would increase our understanding of the worldwide church, capitalize on the missionary experience, improve BYU's ability to appropriately change with the times, and be more creative. I believe that our students, if they are to be leaders, they must have vision, and that vision requires both depth to see the future and breadth to understand the implications of the future. Some good things are already underway. Several colleges at BYU have formed or are forming a Center for Creativity. These colleges include engineering and technology, fine arts, business, education, humanities, general education, and museum of art. We are working hard to cross the normal academic boundaries. In the Creativity Center, we will be helping humanists think and act like in scientific terms. Quantitative thinking, use of models, objective viewpoint, reductionism, experiments, mathematics, determinism. We will also help scientists think and act in humanist terms. Qualitative thinking, use of forms, subjective viewpoint, holistic consideration, technique, aesthetics, and diversity. We hope to provide bridges between the discipline. Creativity is one bridge. Other bridges are critical thinking, symmetry, beauty, technology or technique, and simple elegance. Scientists need to think in terms of absolute models, trying to avoid thinking about deviations. Humanists also think in terms of models called forms, but are quite happy to deviate, especially to demonstrate individual creativity. This is clearly an area where a dialogue would be beneficial to both parties. I think that we will be personally enriched when we take the effort to make trips into each other's territories. When we do, we will gain a greater appreciation for their thinking, methods, and understandings. Remember that the phrase narrow-mindedness implies less than the entire scope of thinking. It is constrictive and divisive. As we gain knowledge in these other fields, we will likely enrich work in our own field because of our increased ability to think laterally. But we may also make contributions in the new field, especially if we are taking that tour jointly with someone from a foreign country. Imagine the creative output that might have emerged had Shakespeare and Einstein joined together. The Lord has said that Zion consists of people of one heart and mind. I don't think we can do that without understanding each other. I pray that we, students and faculty, will make the effort to understand fields outside our majors at much deeper levels. I hope that students will take the fullest advantage of this breadth opportunity through their general education requirements, and then will continue to explore foreign territories, literally and figuratively, for the rest of their lives. I hope that the faculty will do likewise, and that they can be examples and mentors in this wonderful and enriching experience of life. This I pray in the name of Jesus Christ. Amen.